The next speaker is Dr. Srinivasan Ramani from The Hindu. He's the Deputy National Editor and Senior Associate Editor with The Hindu newspaper. He anchors The Hindu's explanatory data, opinion, and science journalism teams and sections while doubling up as an editorial writer. The teams that he leads contribute to products such as Data Point, Text and Context, the Science e-paper pages, and interactive data-driven articles on thehindu.com, besides e-books and the fortnightly book, The Hindu Surf and Dive. He has a PhD in comparative politics and political thought from Jawaharlal Nehru University, besides training as an engineer who worked in India's software consulting industry before embarking upon a career in humanities and journalism. So with this wide variety of experiences, Dr. Srinivasan Ramani comes to talk to you about data journalism and science. He's just about to join us.
Good afternoon, everyone. Uh, First of all, thank you for inviting me here. It's a privilege to talk to budding journalists here. So, unlike the previous speakers, I'm not in any way connected to science. I'm more of a journalist. But what I would like to tell you through this presentation is that the method of doing data journalism in the Hindu and elsewhere is largely related to how you conduct experiments in science, or you work, the way you do science, right? It's not very different. That's what this presentation will try to explain to you. Let's start off with an example. How many of you saw this story already? Okay, I'm lucky, not many have seen it. So, yeah, there will be some suspense. So, what we wanted to measure what is called heat stress in Chennai during the summer. Unfortunately, the idea to do this came to me a bit late. Otherwise, we would have done it during peak summer. But we did it on June 9th. So, can someone tell me? We've already gone through June 9th. So, can someone tell me what could have been the maximum temperature on June 9th? Rough figure. 39, right? Someone said 39. Okay. 49. Yeah, thankfully, we are not that bad. We are not in Rajasthan. But the actual recorded maximum temperature was 36 degrees Celsius, right? So what we did was we know that. Yeah. So on this is visible to you, right? So maximum temperature recorded on June 9th in Chennai was 36 degrees Celsius. But as all of you would know, how you feel, hot temperature is a function of not just temperature, but also humidity. If there is high humidity and also high heat, the discomfort is more, right? So clearly, heat stress is not just a function of temperature, but is also a function of humidity, right? So if we calculate, let's say, over time on the same day, temperature and humidity for a set of people, right? And find out if some people experience more discomfort than others, that will become a story, right? So that's what we try to do. So how did we do it? We handed out devices to 4 people. The first person was a cook, okay? The second person was a fisherman. The third person was an industrial worker, and the fourth person was an auto rickshaw driver. He did not want his photo to be published, so we had to come up with a similar image. Now, what we noticed was, all 4 of them, what we did was, we handed out certain devices that will measure humidity and temperature in real time, every 10 seconds over a day, at the same time for all these 4 people. So from 9 a.m. in the morning to 9 a.m. the next day on June 9th and early June 10th, and see whether there is any variation in the way they experience heat discomfort, right? So what did we do? We handed out devices to them and kept it in their, wherever they were going, at home, at workplace and so on. So let's look at the first person, the tiffin cook. So when she woke up in the morning and, got ready to work, the temperature she experienced was 32 degrees Celsius. But the heat index, that is including humidity, at 9 a.m. was close to 47 degrees Celsius, right? Then look at this. This temperature keeps increasing. So at 9:30 a.m. she starts her work duties. She's actually a cook who cooks tiffin items for working class people. And look at this. The actual temperature reading is 32 degrees, 33 degrees, but the heat exposure that she's facing is close to 43 degrees. And as you see, right at the time when she is almost done cooking, the actual temperature reading is around 49 degrees inside where she's doing her cooking. And the heat index, that is a combination of humidity and temperature, is close to 69 degrees Celsius. Right? Later in the day, things get better. In the night, while actual temperatures fall down. That day on June 9th, we had rains in the evening, so there was some relief from the heat, and therefore temperatures fell to 31 degrees Celsius. Still, the heat index for her was close to 40 degrees Celsius. The reason why this was the case is very easy. You can look at the, this is the heat index reading. If you see the time when she finished cooking, the heat index peaks to 69 degrees Celsius. At one point, it actually went far high, but that's because she kept the machine right near the stove, so the readings went haywire. But essentially, if you notice, till the time the rains actually fell on at 4 o'clock in Chennai, you notice the heat index reveals that she has gone through significant discomfort, right? And even during the night, from 9 to 12 a.m., you notice the heat she's experiencing is quite high, and again goes up the next day in the morning, right? So this is her work environment. If you notice here, how do I have to do this here? If you notice this, she works under an asbestos sheet roof, right? And this is her work environment, and this is where she cooks. Look at this. This is the device that we had asked her to place, and she had kept it here, and that recorded very high, heat index. Right. Let's move on to the next person. This is Anand, who is a fisherman, and he also started tracking. Set the device on at 9 a.m. and at that point, the temperature that he experienced was close to 34 degrees Celsius, but the heat index was close to 43.2 degrees. Roughly at this time, he had already started to venture out in the sea, and at around 10:30, he did go to the sea, and at peak noon, he was already into the sea. And look at this, he was experiencing 48 degrees Celsius was the temperature that he was encountering, and the heat index was close to 70 degrees. We asked him, why do you have to really bear this kind of weather? And he said, only when there is, only during noon, do the fish actually come to the surface, and it's easy to catch them. That's why even if I go into the shallow waters or deep waters, it's easy for me to fish, and therefore we have to brave the heat, come what may. Again, this tells you that this shows you the kind of exposure to heat that a fisherman has in Chennai. Right? Thankfully, after 4 a.m. there was rain. He had by the time come from the sea, and since he's living close to the ocean in Nochikuppam, right near the beach, the heat index that he was experiencing is much lesser. Right? That said, again in the evenings, the heat index, as he goes home from the beach and goes inside the homes, the heat index starts to increase again. That's because he lives in small houses with very little ventilation. So that's the reason why his exposure goes up. So yeah, so you get the picture. Let me show the full. Yeah, if you notice, the heat index peaks to 69 degrees at around 1 p.m. That's when he's right in the ocean. Okay. This is our respondent, who's a fisherman. The same thing we did it for an industrial worker as well, right? This industrial worker was suppose Prakash his job is to basically polish steel pots, right? and there is a lot of heat inside the premises where he works, right, with very little ventilation. So look at this again. He starts working at around 9 a.m. and already his heat index is 44 degrees. Right. And it starts peaking at roughly at noon. The actual temperature that he's experiencing is close to 40 degrees Celsius, which is what all of us feel, but luckily we are in AC rooms. But the heat index peaks to around 66 degrees Celsius. Okay, the same you can notice in the graph here as well, right? And then the auto driver, similar story. This is one of his co-workers, and this is the kind of environment where they're working. All right. The device was placed somewhere there. We couldn't take a picture of it, but here we go. This is with respect to our auto rickshaw driver. Similar story. Starts off with somewhat less discomfort, but as the afternoon wears on, notice he experiences very high temperatures, and this also peaks close to 55 to 57 degrees Celsius, right? So his heat index peaks to 57 degrees Celsius at around 3 a.m. And when the rains fell exactly at 4 p.m., our friend was so considerate that he felt that he should not damage the device, so he put it to off, which is why we didn't have data. But it's also a good way we could actually capture that this is exactly when the rains happened, from 4 a.m. to around 7:30 a.m. And then we captured his heat exposure in the night as well. And if you notice here, even during the night, the heat index levels are quite high, which is again a function of where he lives with very little ventilation. So, of course, we went on to send a reporter to their homes, try to understand the environs that they occupy, their workplace and so on, to get a better feel of how they have to face this heat and how they cope up with the heat and what they demand and so on. And then we talked to experts and found out ways to get mitigation plans to help these people and so on. So, let me get back to the presentation. So, this technically is not as typically a story done by journalists, right? What do? We lean on scientists to do the experiments, do the primary data collection, and then we report on it. But this is an experiment we tried where we assembled our own hardware devices, basically Arduino devices. I'll show you the methodology. So first we ideated, then we procured hardware devices which look something like this. Okay, these are hardware devices. We actually assembled 6 of them and gave it to 4 people. These are the batteries. It had an on-off switch. I'll make it a bit more clearer. Yeah. Anyway. So this okay. Yeah. Yeah, so this is the temperature sensor. Inside there's a microcontroller and a data card and an SD card to store the data. So we got this assembled by a hardware engineer. We took the help of GenAI to first find out whether it is feasible to do something like this, and then got a hardware engineer to assemble this, and then provided the devices to our respondents. I'll show you. And asked them to take a photo on their WhatsApp with their location. We notice here, this is where they place their device, right? So, and then instructed them how to set it on and capture the data over a 1-day period, right? Then once we got this data, in order to understand this data, we sent our reporters back to our respondents, to go to their homes, sit with them, talk to them, and find out why is it that they're experiencing such high degrees of heat stress over and beyond the actual temperatures that they're facing. And then we got experts to actually weigh on this issue as to why is it that residents in Chennai are now facing a higher level of heat stress than before, right? And got some views from them. And then also got some policy suggestions to round off the story. And then we went on to present this story as an interactive one, which you just saw, right? So, yeah, let me not get into the process and so on. We also got a print version of the article done. Yeah, this is a print version of the article, just replicated the same story for print, right? All right. So and then this is something that involved a lot of teams, not just the data team which I anchor. So there was the data team, we had reporters helping with setting the context for the story, we had photojournalists helping us with, you know what, we had hardware consultants who actually helped us assemble the devices, we had a design team helping us to shape the story online and also on print. We had an editorial coder who actually wrote the code to, you know, be presented in interactive form using JavaScript. And then we had the software product team which actually deployed the story. If you're interested, you can go to this video that we came up with interests journalists as to how we did it. So let me move on. So, and the kind of tools we used were not that expensive. For each device cost us close to 1,600 rupees to assemble the whole parts, right? An Arduino Uno microcontroller, which is an open source hardware device, which DH22 temperature sensor, which captures both humidity and temperature, and an SD card to store the data. That's all. This is basically the setup. And we used, and then we used spreadsheets, D3JS, etc. to present this story. Right? So, why did I want to start off with this? The point I wanted to emphasize is that journalists today cannot be just restricted to doing breaking news, right? We have to, at a time when there is a proliferation of news, proliferation of social media, and news consumption through push notifications and so on. Legacy media such as the Hindu and other newspapers are at a point of inflection. Our print readership is declining. How many of you read the article in print? How many of you read newspapers, print newspapers? Okay, and this is a very small minority of journalism students. Imagine if I take the sample, in the general audience, it will be even lower, right? So at a time when there is more information, but very little gatekeeping or regulation, that is what we see in social media. At a time when there is news that is unfiltered, people report what they see and they don't really provide context on social media. At a time when there is an explosion or a proliferation of fake news or false news, and at a time when users are preferring these mediums over traditional mediums like print, it is incumbent upon journalists, right, to not just think about presenting news in terms of just press releases or reporting what the government tells you, or going and doing in-depth stories, but also to add context to what we are to that news. And that's the only way we can, tell the consumer that, look, what we are providing is still of major, value to you, and that's how we would get readers to come and read print and also diversify our products. So essentially, now we are trying to, diversify our products to not just present news and be a newspaper of record, but we want to provide context, we want to organize news better, and we want to inform citizens better, right? And in this endeavor, we feel that data journalism as an entity within journalism plays a very strong and an important role. Inherently, data journalism is objective. Inherently, it's verifiable. If I use official sources and if I give you the methodology very transparently, then anyone can replicate what I did, right? If a scientist like you come and tell me, he comes and tell me that, look, there's something wrong with your methodology, I can hand over the devices to him, and he can verify and see if this really is the right way to do it. And if there is a problem, he can reach out to us and we can correct our story. So there is a inbuilt peer review process and also verifiability process that is inherent in data journalism. All this actually increases credibility. We know in the age of social media that while people are consuming more news on social media, they are also not trusting news enough. So you look at the Reuters latest digital media report, you will notice that more and more readers are actually consuming news via video and via push notifications on Instagram or Facebook or Twitter or YouTube and so on. But if you ask them if they trust the news that they're getting on those platforms, a large majority of them say no. They don't find these things to be credible enough. So if credibility is such a premium requirement, then print media has a role to actually cater to that value, right? And therefore, we have to present our data in a credible manner. And data journalism inherently increases the credibility of our reporting. So then, for functional reasons, a visualized data story has a greater appeal than just text. As you saw the video, as you saw the presentation there, I did not have to read any text there. All I had to do was show you images and graphs, and it was comprehensible. Tell me if it's not. Generally more comprehensible, right? They say a picture says something that 1,000 words will express. A graph could do even more than that, right? And for print media in particular, because if I'm showing things in the form of graphs and charts and images, there is the possibility of brevity and space conservation, because newsprint prices are quite high, so we can save on cost as well. And of course, because of inherent objectivity, verifiability, and then the method that is rigorous enough to tell you a story, therefore it, in my opinion, leads to a more informed audience. Having said that, what exactly is the scientific method that we think we should follow while telling a story using data? Now, we believe that just like a scientist would go about a research project, or a social scientist will actually go about a humanities or a social science project, a journalist should approach a data journalism project as well. So essentially, what I have to do, like for example, if I want to stress, can I just have some water? So, for example, if I want to do something on heat stress in Chennai, then I should have an hypothesis. The hypothesis should be that people living in working class environments with very little ventilation and due to the very nature of their jobs will feel significantly high heat stress. Right? This is a simple hypothesis, but it's a workable hypothesis. So once you have the hypothesis, then you come up with methods to measure that, or rather to track whether the hypothesis is correct or not, right? So that's how you approach a science project or a social science project, and that's how you approach a data science story as well. So or a data journalism story as well. So once you do that, you conduct what is called an experiment, right? In this case, we did a primary research. Sometimes it could be using government data. Sometimes it could be data scraped from different sources. But the process is still the same. You analyze the data and find if your hypothesis is right or wrong. If your hypothesis is disproved, then alter your hypothesis and then find out if that altered hypothesis is accurate with the data. Unlike scientists, we have the luxury of saying, just doing a story, saying this hypothesis doesn't work, that itself is a story, right? So the process is similar across, verticals, right? Then, more importantly, we should not do a data story just because we have the data. There has to be a compelling narrative that adds to the public debate, right? Or adds to public awareness, right? So people think data journalism means simply producing stock market numbers or putting up cricket scores and so on. No, we need to actually present that data in a way that adds to a narrative that is already in public discourse. Like for example, all of you know what is happening in Bihar. There is a special intensive, exactly. So if we need to add value to that, then we need to actually, with the available sources, figure out a way to tell whether this kind of revision actually helps the people or actually disenfranchises the people. So, that's what I mean by saying data not for data's sake, but for a narrative, right? And more importantly, data journalism cannot work in an island. It has to supplant all our old school journalism formats, right? So for this story, in the heat story, for example, I can just take the data out and do it as a simple graphic story saying the cook experiences 69 degrees, the fisherman experiences 66 degrees, and so on. But the real story is in explaining why is that the case, and that's why we need to have boots on the ground. Just as we do reporting, the reporter has to go and meet these people, observe their workplaces, observe their the standards of living, to understand why is that they experience heat stress, and the reporter still has got to talk to the expert and get the view. So that's old school journalism, data or not. But that can't be supplanted by data alone. Data has to supplement that form of journalism. Finally, data journalism need not always have answers. That's the job of scientists to find answers. We'll present questions based on what we see, and so we can actually further the idea of research. I'll come up with a lot of examples that will tell you how what we did actually furthered the idea of research, right? Okay. So quickly to summarize, what are the different kind of data stories we do? In terms of bare skeletons, we try to understand why a particular policy decision has been taken, try to evaluate it using data. We try to connect two different dots, right, to come up with a link. Like for example, we had electoral bonds data. We also have data on, let's say investigations on corruption and so on. Try to link these two and see if there are patterns that emerge. Then, based on understanding of what the data presents, build a context, and then from the context, form a narrative, and so on. So how do we do it? We try to find authentic data sources. If the data sources are with the government and it's available online, get it directly. If it's not available, use RTI. If it is available but in unstructured formats already on the internet, use scraping and so on to get it. And once the data is arrived at, visualize the data using charts. You might see some patterns emerging from those charts which you didn't anticipate. And then adjust your hypothesis and explain what you find and come up with conclusions. Right? Technically, we only use verified and official data as much as possible. So if there's a private company doing a survey and finding something and giving it to us, we normally say, no, sorry, we can't do that, because unless they have a very robust methodology where they clearly have selected their sample in a scientific and unbiased manner, we generally say no to that kind of data. We only rely on official data released by our Ministry of Statistics, Planning and Implementation and so on. Right? Now let's get to what are the different types of data stories we do. This is a rough classification based on the work the Hindu does, so I apologize for that. But the other media houses could do more, or they could have other types as well. But this is a classification of what we do. And since we have been doing this for close to a decade now, or rather than more than a decade, I can say with a fair bit of confidence that if you classify data stories done generally by journalism, generally by media houses, which includes the New York Times and so on, you can roughly classify them into these 5 categories. The first category is simply showing a series of graphs and drawing a simple conclusion, because these are trends, it's easily comprehensible. Then identifying certain patterns, and then highlighting certain correlations, going to the next level. And then thirdly, very simply, a lot of claims may be made by government, by others in power, or and so on. Fact check them. That's the third kind of story. The fourth story is actually provide context by clearly establishing causal relationships, not just correlations, but actual causation. And the fifth one is basically conducting deep dive investigations. So, which includes collaborating with other teams to supplement the kind of work we do, or supplement the kind of work we do. So let me provide quick examples for each of them. So this is a story that simply draws a conclusion. Technically, there is a fault in this story. I want some of you to point it out. But look at this. What we have done is we look at chart 2 in particular. If I can. Okay, quickly, this is PM 2.5 level data for Delhi, Noida, and Gurgaon over time, right? From January 24 to October 24, right? This is simple data from January to October 22, daily data. You notice the peak 2.5 values are in somewhere in mid and early January, right? And it starts going up again from October. Okay. Now, most of you would know what is the general cited reason for, pollution peaking in the winter? Can someone tell me? Correct. Burning off the harvest. Correct. Yeah. So basically, farm fires. The stubble is burnt, and the residual. The residual ash or whatever. Results in pollution, and that's what is felt in this urban environments in North India. That's a general analysis, right? There are other factors, vehicular pollution and so on, but this is seen to be one of the major factors, and governments have time and again emphasized that farmers need to halt this practice or alternatives need to be found and so on. And what we found was, look at this graph, this is based on satellite imagery, right? And we noticed that from 2020 onwards, almost in all states where stubble burning is significant, the numbers have fallen drastically. So in Punjab, for example, the number of farm fires, okay, that has come down to close to almost 2,500, right? UP is close to 1,000 plus or so. Haryana is also roughly 1,000 plus or so. So this is in comparison to 2020 when you had close to 12,500 farm fires in Punjab, and in 2016 it was even higher, close to 17,500. So the simple conclusion from this was, look, yes, stubble burning could be a reason, but if you look at data tells you that stubble burning has actually decreased over time. So this can't be simply taken as a indicator of continuing indicator of the reasons why North Indian cities are facing pollution. Now, one caveat is that this data is entirely based on satellite data. And if some of you had followed this information closely, you would note that there is an issue, there's a flaw in this story. Can someone tell me what is the flaw? Yeah. Exactly. Can you say it loudly, please? Okay. Yes, very good answer. So what happened was, this was corroborated later, is that the farmers were aware when were the satellites actually tracking the fires. So they were changing the time to, they're changing the time when they were burning the stubble to those hours when they knew that the satellites were not tracking it. So yeah, so that's how actually these numbers were not accurate. The farm fires were considerably higher than what these numbers revealed. This is satellite data basically, and then the Indian government actually said that we will also deploy, remote sensing devices to capture it over a longer period of time than just depending on specific cars. Anyway. So why I wanted to highlight that was these numbers can seem compelling, but and we can draw simple conclusions from it. But if the data source itself is a problem, right, then this could lead to long conclusions. So technically this story should, actually we did update this story later on, but this earlier story had a problem. So I wanted to highlight that. Right. Let's move on. Again, very simple conclusion. What's India's tuberculosis burden? It's falling, but still as a percentage of the world's tuberculosis burden, India's burden is high, as simple as that. Nothing more to discuss in this. Right. Let's move on to the next one, pattern analysis. Right. So we wanted to find out. We all know climate change is, we are already in the era of climate change. We are already in the era of global warming. We wanted to find out if cities are experiencing relatively higher temperatures compared to the norm in the last 30 years. Right. So we wanted to do this city-wise. Right. So we looked at daily temperature data for whenever it was available. I think it was available from, if I'm not wrong, from 1950 onwards. So we had data from 1950 onwards for each city. Bangalore, let me just open the story for you. Yeah, so, and what we did was we calculated the average maximum temperatures for metros in degrees Celsius over a 30-year period. So we noticed Delhi had roughly the highest, temperatures in the summer months in particular, April, May and June, 37, 40, 39. Mumbai had relatively lower temperatures, 35, 36, 32. Kolkata also similar. Chennai was high and Bangalore was somewhat low, right? Now, generally speaking, in terms of how we feel the heat, we would have thought that Chennai and Delhi are the worst affected cities in terms of temperature increases in the last 30 years. But the data was contrarian. The data said something else. Actually, over 30, the number of days when Mumbai experienced temperatures above the 30-day average above the 30-year average was much higher than other cities. This is what we found. Right? So Bangalore and Bombay actually saw more above average heat days than Delhi, which is somewhat of a counterintuitive thing. But we also noticed that Delhi still had the higher maximum temperatures, but global warming and also the way urbanization has happened in Bangalore has significantly started to increase the average temperatures in these cities, in Bangalore and Mumbai. So a simple pattern analysis data point. I'll move on. Okay. Then we also wanted to do what is called fact checks, right? I'll show you one graphic we did. Okay. This was trying to understand what was the cause for the floods in Kerala, right? So what we did was, this is sometime in 2018. So we wanted to source information from the meteorology department on rains, right? Then we wanted to see as to what was happening after the rains, what was the inflows of water into reservoirs. Because of the heavy rains, how much was the spills from the reservoirs, and what was the outflow from the reservoirs. The outflow is controlled outflow. What were the spills, and how were the spills leading to floods, right? So we wanted the full life cycle of the floods. So if you notice here, in 2018, the normal average rainfall was something of this kind from June 1 to August 15. But most days, if you notice, the rainfall was much higher than the normal, right? And in August 15, it had peaked, right? And this corroborated the fact that this rainfall resulted in very heavy inflows during the periods when there was high rainfall, right? And we also noticed that because of this high rainfall, the reservoir levels were quite high, right, before August 15, when the massive rainfall actually resulted in heavy spills. You see here. Notice the spills, right? Many of these reservoirs were spills. And those spills were recorded by flood monitors in rivers and found that at least there were 21 stations. We got data from 8. In all these 8 flood, in all of these 8 stations, we saw that the flood levels were breached, right? So we looked at whether the state was lackadaisical in managing the reservoirs, right? And we did say that they didn't anticipate this heavy rainfall on August 15, and if they had probably managed the dam levels better, they could have avoided this, right? And that was shown to be true with what happened in 2022, right? In 2022, look at this. 5 minutes, yeah. Look at this in 2022, the rainfall levels are similar. In 2018, 2022, almost similar patterns. Many days when the rainfall was above the normal average. But if you look at the reservoir levels, while reservoir levels peaked at around 99 to 100% before the peak rainfall hit, the reservoir levels were lower comparatively in 2022. So we wanted to know why and therefore the spills were very high in 2018, while in 2022 the spills were relatively low. And in fact, in flood monitoring stations, there were many flood monitoring stations which actually recorded flood in 2018. There was not a single place which recorded flood in 2022. So we wanted to know what is it that Kerala did in 2022 that they were able to avoid the situation in 2018. So therefore we went on to interview a dam engineer who told us that in 2018 they were dependent on only one model, the IMD's forecast model saying this is what the rain is going to be, and they managed the dam based on that. But in 2022, they actually looked at several models across the globe, and then if even one model said that there is going to be heavy rain, they immediately let the water out from in the dams. So that way they were able to avoid the floods. All right. So yeah, there you go. Again a fact check story. Now these kind of stories, none of us are water experts in our office. There is one water reporter, but data journalists are not water experts. We were able to make these associations and connections because we did one story in 2015 on Chennai floods. And because we developed some expertise based on that, then we were able to do the Kerala story. And then we were able to do more fact checks later. Like for example, there was flooding in Chennai last year in Satanur Dam, and the same process we could use to find out whether it was mismanagement or simply heavy rains that resulted in the outflow of water. Right? Other fact checks, for example, last year during the elections, there was this talk that the voter turnout was low, and the ostensible reason often offered was that the temperatures were very high, which is why we got low turnout. So what we did was, I went on to compare the temperatures experienced by voters in same constituencies in 2014 and 2019, because luckily elections have been held in regular intervals since quite some time now. And then I found out that in some places temperature went up, turnout went up. In some places temperature came down, turnout came down. In some places temperature went up and turnout came down, and vice versa, right? And then I calculated correlation coefficients and found that there was very little correlation between temperature change and turnout. Okay, and then I split it again further. Is there a higher correlation in urban areas? Because we know in urban areas we have more concrete, therefore the felt heat is higher. So I found there was some correlation, negative correlation in urban areas, but even that is low. So we were able to, using correlations, say that the rise or the lack of turnout is largely due to political reasons and not necessarily due to temperature reasons, as the election commission and others were claiming. All right, okay, move on. That's a fact check. Yeah, I have very little time, so I'll just rush through. Okay. Like providing context again. We wanted to study why railway accidents were peaking last year, and the general refrain was that the railway was lacking funds and therefore was not able to implement the Kavach scheme quickly enough, which is the reason why many collisions were happening. We actually found out that it was not necessarily finance was the reason, because if they amortized the cost for Kavach implementation over 10 years, it would have well fitted within the budget. But Railways' focus on spending was elsewhere, and that's the reason why they were not implementing Kavach. So, the context-driven story. And of course, deep dives, like the heat story. This is something we did during the COVID-19 period. We actually calculated the excess deaths that were, we calculated excess deaths for state-wise. We calculated for 10 states, and we roughly came up with an estimate that the excess deaths were close to 6 times more than the actual death toll, according to one model. Another model said five times, another model said 3 times. So roughly between 3 to 6 times, there was an undercount of COVID deaths. And the government actually got really pissed with us. They said this data is trash, don't trust it. We actually used CRS data, the government's own data, to come up with this. And the WHO went on to also calculate excess deaths based on our investigations from our RTA report. They estimated close to 5 million excess deaths. But now the government, after 4 years, has finally released its own estimate of excess deaths, and it said only for 2021 there were 25 lakh excess deaths, and that's close to 6 times more than the actual recorded deaths of 3 lakhs. So I just wanted to show their estimates and our estimates are almost a match. So yeah, quickly. So as I said, 5 different types of data stories with simple interpretation, looking at correlations, trying to come up with causal, seeing fact checks, and of course deep dives. Right? What are the tools we use? Of course, in order to download data, we use scraping tools like Python and so on. We also get data using RTIs. We take recourse to mostly data and so on. We analyze data using spreadsheets, Tableau, R, and so on. We also map data using Tableau and so on. Anyway, these are the tools we use. Right? One great thing that has happened to us in the last few years is that we have started relying more on AI. Before GenAI came in, we actually did a story just with machine learning. So we wanted to, for example, find out, is Muslim representation in Indian assemblies decreasing over time? So what we did was we looked at all the names of MPs and MLAs, and then trained a program that from babynames.com, to find out whether a name is Muslim or not, and then using the trained data find out whether the Muslim representation in assemblies and parliament is coming down or not. We verified it using our own sources, and we found out the findings are startling. I'll send it to you later. So Odisha, for example, hasn't had a Muslim MLA or MP for last 15-20 years. Anyway, and now because of GenAI, a journalist can be a coder. Before we had to depend upon software engineers to actually do interactives for us, but now we can do it on our own. Show you this. So this is a comparison of different elections, 2014, 2019, and 2024, and you can parse the data on different variables like East India, the contest is bipolar, and so on. You can zoom in and get the data. And all this was done entirely by me without knowing anything of code. All I did was using GenAI prompts to get this done. So the possibilities are endless now. How many of you attended yesterday's seminar on, ECJ had a seminar on? This virtual reality. Yeah, virtual reality. Yeah, you attended that, right? Now that is something we want to do. That's a frontier we have not yet reached, but sophisticated journalism using virtual reality is something that the New York Times has cracked. And now that we have GenAI tools, those hurdles are not that huge. We can actually use these tools to get things done on our own.
We need to have questions.
Yes, okay. So I'll just end here. Anyway, I'm just going to repeat myself here. So I'll just end here. These are the conclusions. So data journalism has evolved now and has become a core product of legacy media. As I said, it increases credibility and so on. And I talked about the methods. And the methods are similar to how you do science journalism. For science journalism or any kind of journalism, the methods are similar. And it's almost like doing a science project. And then, as I said, GenAI tools have made interactives and complicated IT and data tasks much easier. Thanks. We'll take questions. Yeah.
My question is from the sir. Sir, you said that data is not the sake of data, it needs justification. So opinion polls are very much part of the data journalism. But we have seen how miserably they failed. Like in the Haryana election, nobody was expecting that BJP will win. So how this changed, like why they are failing, why opinion polls are failing, what they are doing wrong in it, like the procedure is wrong or people are not opening up.
Okay. Yeah. Good question. So, two things. Number one, we have to be careful about what opinion polls we publish, right? And if you are publishing data from opinion polls, we also need to mention if they have provided a methodology or if they are providing more granular information. Like some opinion polls just give you rough seat estimates, they don't give you vote share estimates. Some opinion polls give all these details, but they don't tell you what is the sample size they use, how they interviewed, was it telephonic interviews, and so on. We have to mention all those points. As to the question, why are opinion pollsters failing? See, failure is expected. It's not easy to, especially in places where the contestation is more diverse. It's very difficult to get accurate answers on who is going to win or who is not going to win. But the opinion pollsters of the higher standard, like Lokniti's CSDS's Lokniti, or to some extent Axis, they have been able to get the vote share numbers somewhat right most of the time. Not all the time, but most of the time. But others, I don't generally trust. Now, the reason why some agencies like Axis are failing more regularly now is that I've written something about it, you can search for it. Srinivasan Ramani opinion polls, the Hindu will get it. Basically, what I feel is that Axis, for example, relies on almost like a brute force method. They send their surveyors in a vehicle, track where they are going, and they go and meet respondents in different places. And their approach is surveying as many people as possible. What they don't do is they don't go technically to the houses of people or sit and have conversations. They just accost someone and they say, who did you vote for? Take that reading and go on. Now in 2024 Lok Sabha elections, their gender split was 69-31. 69 males and 31 females. The reason for that was because they were accosting people on the street, right, not in their homes, and that skewed their values dramatically. So they had actually extrapolated the data for 31% of the women voters to the entire population, to 50 basically, and then arrived at their numbers. That's why they got it wrong. The other mistake these pollsters make is that marginalized people generally are now very distrustful of anyone coming to them and asking who you voted for. And there has been a behavioral change as well. So unless you make them comfortable by actually going to the setting and just taking some time with them, listening to them, not just ask them directly who you voted for, but rather asking about other things, why they did vote, why are they not voting, what are the reasons for that. So this is like more like an ethnographic exercise rather than a polling exercise. Those people generally don't open up, and sometimes some sections, especially Dalits in North India, have now, and of course minorities have started to also mislead voters. So they are afraid to actually reveal their, the choice, and that's why some pollsters are getting it wrong. So on the other hand, more engaged pollsters like Lokniti come closer. Of course they also make mistakes. That's because they take a post-poll approach. They don't do an exit poll approach. They don't just accost people. They clearly come up with a good randomly and stratified circular random sample. They devise it. They provide the methodology for everyone to parse, and then they send their surveyors who are generally social science trained to go to those places. They have a good gender balance in their surveyors also, so that women are comfortable speaking to women and so on, and then they get their information. So that's why their approaches are better. Unfortunately, the data that they provide is not provided immediately. The television channels jump onto these other pollsters because they have to present the results right at 6:30 on election day itself, which is why the impression is that every pollster gets it wrong. But more seasoned pollsters who take some time in coming up with the data actually get it somewhat more correct, and the reason is why the reason is the kind of methodology they use to actually arrive at this. Hope I answered your question. Yeah.
Hello. Yeah. So, sir, you spoke about how complex systems emerges from basic principles like the symmetry breaking and the models such as the Ising model. So, I want to ask that with companies like the Colossal trying to recreate extinct animals, much like Jurassic Park, the movie. How do you view this idea of building life from zero, and what role should science journalism play in covering its risk and ethics?
So, I'm not a science journalist. I'm a scientist, and certainly I see the appeal of bringing back extinct animals to life using genomic material. There are, of course, big ethical concerns. I think that's where actually science communicators, I don't use the word journalist in particular because a scientist can also be the interlocutor or the mediator between the public and scientists. Science communicators can play a big role. So per se, bringing back extinct animals doesn't sound that troubling to me, but when you start asking questions, do I bring back my dead son back to life? I mean, it may seem like fun to bring back the dodo to life, but the same technology can be used to bring back my son who died to life, right? Now, what we often confuse is just because you have the same gene doesn't necessarily mean you're the same person. Just because you have a clone doesn't necessarily mean the clone is you, right? Because apart from the genes, and in fact, that's how I think your question is very intimately connected with what I was trying to show. The genome is only one part of the story. It's an important part of the story, but there's a whole lot of extra genetic stuff that is going on to make an individual organism. Okay, and I'm not even going into this whole question of nature versus nurture. Okay, even sticking with the pure biology part of it, there's a whole lot of extra genetic stuff that is going on, right? And so when I'm taking this decision that, for some emotional reasons, I want to bring this to life, I may be doing it for completely wrong reasons, and I may actually be sorry for, those decisions later on. And so before I take that decision, I should be completely aware that the reasons I'm doing something for may not actually be the right reasons. Okay, so as far as bringing back, extinct animals to life, the problem, as I see it, that we have already done a fantastically bad job of the existing ecosystem management. So in some other projects of mine, I work with ecologists, basically to decide like what are the pressure points of an ecosystem. Okay, so in ecology, there's this concept called keystone species. So like the keystone, which kind of puts the entire arch stable. So you take out the keystone, the whole thing will come crashing down. The concept in ecology is that there are some species which basically functions to anchor the entire ecosystem. You take that particular species out, or if their population plummets, the whole ecosystem is going to come crashing down. It's very hard. Okay, so this is the thing. So often you might think that it's the plants or like the bottom of the ecosystem which is the keystone species. No, sometimes it's the very apex predator which is the keystone. Okay, so this is that's one of the things we work on, like figuring out what is the keystone species in a particular ecosystem. Now, when I work with ecologists, so this particular ecologist friend of mine, he works in University of California, Santa Barbara. So he worked on reintroducing wolves in the Yellowstone National Park. So wolves had gone extinct, and in about in the 90s, there was a conscious decision taken to reintroduce wolves in the Yellowstone. And what he said was that the reasons for reintroducing wolves turned out to be very short-sighted, and in fact, it resulted in human-animal conflict at an unprecedented level, especially in the borders of the park. Another ecologist I've worked with, who works with in African parks, has said that one of the big questions that ecosystem managers face is like, do they focus on preserving animals which bring in American dollars? Or do they say that, no, our purpose is to preserve as many species as are possible? Now, there's a big conflict. People come in to see the elephants, but elephants also take up huge amount of resources. So in trying to, make sure that the resources are available for the elephants, you might be actually, causing other species to, so how many species are worth preserving elephants? So all these kinds of questions come up, right, which are not pure science questions. And I think we are very bad at making these decisions, especially when it's a question of, do we have enough money for running the park? Do we save the elephants so that rich American tourists come and pay for it? Or do we actually put more importance on maintaining ecological stability? So those are the actually important questions which we have to consider.